Okay, example 7. A man is 1,200 feet due west of a woman. The man starts walking south at 3 feet per second. 3 minutes later, the woman starts walking north at 7 feet per second. At what rate are the people moving apart 8 minutes after the woman starts walking? So let's start off with the beginning scenario. We got the man over here and the woman over here. It says the man is due west, right?
Yeah.
West. It's actually south, but oh well. All right, we'll pretend. So right now, before they move, that's where they are. 1,200 feet away from each other. In my opinion, they were together right here, and they got into a fight, and the man went way over there, just far enough that they could still yell at each other. And then she said, "I never liked the way you thought anyway." And he said, "That's not very nice." And she goes, "Well, I think I should walk north." He goes, "Well, I think I should walk south." And then that's what happened. So there you go.
Happens a lot.
Lots of turmoil here in the math world. Anyway, so they got the man and woman separated by 1,200 feet, and the man thinks he's supposed to go south. So he's going to start walking south. So let's make him walk south. There's the man walking south. 3 minutes later, the woman's walking north. She's walking faster than he is because she's madder than he is. Because she was right. And everybody knows that she was right.
All right.
Now those two dimensions are changing, right? Those are changing dimensions. So I'm going to say the man's distance is x, and let's call the woman's distance y. And the question they're asking us is, how fast is the distance between them changing 8 minutes after the woman starts walking? All right. So what their question is, their concern is, how is this distance changing? Let's call that z. Okay. And again, just to highlight how I know 3 variables are allowed to happen here, it says the man starts walking south at 3 feet per second. The woman starts walking north at 7 feet per second. However many rates they give me, I'm allowed to use one more variable than that. So as soon as they give me 2 rates, I know 3 variables can be used. 3 variables should be used. All right. Now looking at this, it creates 2 right triangles, right? Creates this little right triangle over here, this one over here. It's a wonderful, beautiful right triangle. But here's the trick to this problem. Okay, I don't want to work with 2 separate right triangles. I don't want to find this change and that change and add together, because that'd be challenging, because I'm not sure exactly how big that is or how big that is. I could probably figure it out, but it would be really challenging. The better way to do this problem, I'm going to clone this, maybe. There it goes. Clone. If we drag this down to the bottom of the man's path, right there, and we drag this over here, like so, what we've created is this right triangle here that has the same hypotenuse. The bottom side here, the distance between the man and the woman is 1,200 feet, right? East to west. That's not changing. If they're 1,200 feet apart, he's going exactly south, she's going exactly north. The east-west distance between them hasn't changed a bit. And this dimension over here is not just y, but it's actually x plus y. Would be that dimension over there. So my 3 sides of my triangle are z for the hypotenuse, x plus y for the vertical dimension, and 1,200 for the horizontal dimension. Creating myself one simple right triangle. The Pythagorean theorem then would be leg squared plus leg squared equals hypotenuse squared. Uh, 1,200 squared, so 12 squared is 144, and then 0, 0, 0, 0, because there's going to be 4 zeros. And then x plus y squared is x squared plus 2xy plus y squared, and then z squared. There's my relating equation. Looking at the structure of this equation, because we're going to have to differentiate it, right? Anytime we get a relating equation. Constant, derivative is 0. Power rule, product rule, because we have an x and a y being multiplied. Power rule, power rule. So a little bit more complicated Pythagorean theorem, but it's still workable. All right? The other thing we need to know is what x equals, what y equals, what z equals, and what dx over dt, dy over dt, and dz over dt equal. And just a hint, anytime you use the Pythagorean theorem, you need to know all the letters. You need to know what x, y, and z all are. Because 2x, 2y, 2z, just from those three terms alone, all three letters are going to show up in the derivative. So it makes sense to go ahead and figure out what z is in this situation. So, first off, how far did the man walk? Okay, so what we need to know is how fast he's walking and how long he walks, right? All right, so how fast is he walking?
3 feet per second.
3 feet per second. How long does he walk?
8 minutes.
No,
Oh, he walks 3.
not 3 minutes either.
He walks 11 minutes.
How do you know it's 11 minutes, Chris?
3 minutes plus 8 minutes plus 11.
The man starts walking, 3 minutes later the woman starts walking. So the man's been walking for 3 minutes, right? And our concern is, at what rate are they moving apart 8 minutes after the woman starts walking? So the man walked for 3 minutes, then the woman walked for 8 minutes, and the man walked 8 more minutes. That's a total of 11 minutes the man walked. What is wrong with the time of 11 minutes?
It's not in seconds.
It's not in seconds. This is feet per second. 11 minutes is equal to 660 seconds. So to get the distance the man walked, we take his rate, which is feet per second, times his time, 660 seconds, and the seconds cancel, giving us feet. That would be 1,980 feet. And I do want feet because that's 1,200 feet, right? Distance between them is 1,200 feet. All right. All right, let's look at the woman. The woman's walking at how fast?
3 feet per second. Or 7 feet.
7 feet per second. And how long does she walk?
8.
Very good. Her time is 8 minutes, which equals 480 seconds, right? Again, that's feet per second, so we need the time in seconds. 480 times 7, that'll be a 0 and a 6 carry the 5 and 33. The woman walks 3,360 feet. All right, then to find z, the easiest place to find z would be right here. Since we know x and y in this specific scenario, right? Put x plus y there. So let's do that. So if I do 1,200 squared plus parentheses, x plus y, that's 1980 plus 3360, end parentheses squared. Okay, that's 1,200 squared, x plus y squared, right? Equals some number. That's what z squared is, so I take the square root of that, and we get 5,473.1709 feet. 5,473.1709 feet. Again, in your work, go for decimal places, round your final answer to 2. Makes for better, more accurate answers. All right, now let's look at dx over dt, dy over dt, dz over dt. Which one don't we know?
DZ.
We don't know dz over dt, so we know the other two. And again, we have to ask ourselves not just what the number is, but should it be a positive or negative value based on direction and what's happening to the dimension involving that, right? So let's start with dx over dt. dx over dt is the speed of the man, which is 3 feet per second, right?
Negative.
Is it getting bigger? Is his dimension getting bigger or smaller as he walks that way?
Smaller. I was getting bigger.
It's getting bigger, right? He's walking away from the woman, right? So from here, he's going in a negative direction. That's what you might be thinking. But what you're going to ask yourself is as he's walking, does this side get smaller or bigger? That's how you make that decision. So x, as he walks, is getting bigger. That makes his rate positive 3 feet per second. Okay, the woman is walking that way. As she walks, does y get bigger or smaller?
Bigger.
Bigger, and her rate's 7, so her rate is going to be positive 7 feet per second. What's happening to z? Is it getting bigger or smaller?
Bigger.
Getting bigger, right? As they walk apart from each other. So we should expect dz over dt to be a positive answer also. All right. Now, if we go ahead and do this, here's my relating equation. So here's my box of important information, right? I got all my letters found out. I've got 2 of my rates looking for a third, and I got a relating equation relating all the variables in the problem. That's my comfort zone of these problems. That's where I want to be every single time. in these problems. Good relating equation, every value of every variable known possible. Then I just go ahead and do my derivative and stuff. So, derivative of 144,000, so that's 1,440,000, if I'm being a good mathematician speaking these numbers right, is 0, right? Seems like that should really matter to the problem, but it doesn't. Derivative of that is 0. Alright, derivative of x squared is 2x. It's not t, so we put dx over dt. By the way, t never shows up. Don't use t as a variable in these problems. Okay, t is time. Don't use t for variables. So it's always going to be whatever letter it is over dt every time. 2xy again is a product. I'm going to call 2x function 1 and y function 2. So when I do the product rule, I'm going to get 1 d2 is going to be 2x times 1 dy over dt plus y times 2 dx over dt. Alright, so function 1, 2x, derivative of y is 1, but dy over dt, and then 1 d2, function 2 is y, and then d1, derivative of 2x is 2, dx over dt. Then we get 2y dy over dt, and finally equals 2z dz over dt. And just like that, looking at this, it's a big mess, but we know everything in that entire thing except for that one little thing there, right? So to get the answer, I simply substitute all these numbers in there, divide by 2z, and we'll get exactly, or approximately, how fast the distance between them is changing. As soon as we approximate it, we can't get an exact answer. So, 2 times x, that's 2 times 1980, times dx over dt, which is 3, plus 2 times 1980, times dy over dt, which is 7, plus 2 times 3360 times dx over dt plus 2 times 3360 times dy over dt equals 2 times 5,473.1709 dz over dt. What did I forget to do?
Cancel the two.
Cancel the 2's. Let's go ahead and do it. We can still do it here. My bad memory. Pythagorean Theorem, you always get a bunch of 2's, so you can always cancel them out. If you don't do it, you'll still get the right answer. You just got bigger numbers to deal with. What I would do probably would just be go ahead and type all that in the calculator. 1980 times 3 plus 1980 times 10 times 7. Wow, I'm missing buttons here. 1980 times 3 plus 1980 times 7 plus 3360 times 3 plus 3360 times 7. Alright, equals. Alright, the left hand side comes out to 53,400. And the right hand side is just 5,473.1709 dz over dt. So to get dz over dt, I just do that divided by that. So it divided by 5,473.1709. If you want to go 2.7, just to be more accurate, go a few more decimals. It's still on my calculator screen. I'm just going to go with what I got. We get 9.76 dz over dt equals 9.76 feet per second. Imagine if the man and woman were right there and the woman's going that way, the man's going that way. What would their speed away from each other be? She's going 7 feet per second, he's going 3 feet per second. How fast are they walking away from each other?
Really fast.
That's 3.7. What?
10 meters per second.
10 feet per second, right? It is, right? The fact that they're separated by some distance makes it slightly less than 10 feet per second, but that's the way you can check these problems. When you see these people separated by a distance going on parallel paths, the change in distance that comes up should be slightly less than just adding the two speeds together. Because it is at an angle, that creates a little bit of discrepancy. Again, being right next to each other, straight up and straight down, all you do is add their speeds. Separating that distance, it creates a little bit less speed between. And the further they go, the closer it's going to get to 10. If we'd done 5 hours after the woman started walking, it'd be probably 9.99 feet per second. be almost the same as soon as being right next to each other. That's just something to think about. It shouldn't get bigger than 10 feet per second. It should be just slightly less.